Welcome to ST.SEBASTIAN Pre-University College. Namaste student. Welcome to class chemistry. My name is Mrs. Padmaja. Today I am going to explain chapter 1, some basic concept of chemistry. What is chemistry? It is very difficult to define what is chemistry, but in short I will define what is chemistry. Chemistry deals with the study of composition of matter, structure of matter, properties of matter. Now, why chemistry is so important to us and what is the scope of chemistry? As you know that chemistry plays an very important role in our daily life activity. We cannot imagine our life without chemistry. Now here on the slide you can see what are the importance of chemistry. Chemistry applied in soap industry, paper industry, food industry, in clothes, in plastics. Chemistry also contributes in batteries. So, chemistry is very important to us. Now, as I define chemistry which deals with the study of composition of matter, structure of matter, properties of matter. Now, what is matter? What is matter? I think you already studied in your lower classes, that is, what is the definition of matter. But still I will explain again. Matter means anything which occupies space and has mass. Anything which occupies space and has mass. Okay, that means the material around us, material which is present around us are composed of matter. Whatever you can see around you. Okay, that is pen, table, chair, air, etc. All these are composed of matter. Next, we'll move on to the classification of matter. Now, there are two types of classification: physical classification and chemical classification. Now, based on physical classification, matter is classified as solid, liquid and gas. This is also you already studied in your lower class. Now, what are the definitions of these three states? Solid. Solid has both, that means substance has both a definite shape and definite volume. Now, in solid, you already watched an animated video. In that already shown how particles are arranged in solid state. Now, in that, in a solid system or in a solid, particles or constituent particles are tightly held together or very close to each other. So what happened? Each particle or constant particles, for that each constant particle has no freedom of movement. So because of this reason, it is tightly packed and it is very rigid. Okay. Because of this reason, it gets a shape. It gets a shape and a definite volume. Now, in the Next, as a liquid. Now, liquid here, substance has a definite volume but no definite shape. It occupies the shape of a container. It occupies the shape of container. Okay. Now, in liquid, constant particles are close to each other but not as solid. It is strong enough to hold together, but it is not as solid. For each particles, there is a freedom of movement. There is a freedom of movement. Okay. Now, next, gas. In this, substance has neither definite shape nor definite volume. Here, constant particles are freely arranged or freely moving. Okay. Now, next, all these three states, that is solid, liquid and gaseous states, are interconvertible by changing temperature and pressure. That means, suppose if I take an example, ice cube. Now, ice cube is a which states of matter? That is a solid. Okay. Now, if I heat the ice, it converted into water. So, water is in which state? Liquid state. Okay. If I heat water, that means it start boiling. While boiling, what happened? Water vapors are formed. Water vapors are produced. These water vapors are in a gaseous state, or water vapors are considered as a gaseous state. That means solid is converted into liquid and liquid is converted into gaseous state with the help of what is a condition is applied? That is a temperature or heat is applied. Okay. Same way, by cooling water vapor, by cooling water vapor, this water vapor condenses into a liquid state. Water vapor condenses into a liquid state or water on cooling, and on cooling, that is water on cooling, it is converted into a ice. It is converted into a ice. That means three states of matter, that is solid, liquid and gaseous states, are interconverted by applying or by changing temperature and pressure. Next, chemical classification. Now you can see the slide. Matter is classified, that is based on chemical classification. Matter is classified as pure substance and mixture. Okay, pure substance and mixture. Pure substance again classified as element and compound. Then another side, mixture again classified as homogeneous mixture and heterogeneous mixture. Let us study one by one. First, what is pure substance? Okay, so I will repeat. That is based on chemical classification. Matter is classified as two categories. What are those? Pure substance and mixture. Okay, now move on to the definition of pure substance. What is the meaning of pure substance? Now, first I will define. Okay, pure substance are made up of a single component. With a fixed composition. Now, what is the meaning of single component? Now, here already example I have given as water, copper, glucose, zinc. Okay. Now, water. Imagine that you have take a water in a glass, clean glass. Okay. You can identify that it is a pure water. Okay. That means in a water, only water molecules are present. Okay, that means it is entirely pure substance. Same way, if I take copper you can see in the form of wire. Okay, now here also only copper particles are present. Same way, glucose powder or sugar particles. Now here only sugar particles are present. No other components are present. So these such substances are called as pure substances. I hope you understood the definition. So pure substance means it is only a single component. Only one kind of components are present. That is also in a fixed composition. Now what is the meaning of fixed composition? If I take example as a water. Now as you know, the formula of water is H2O. Okay, H2O. Now based on the formula, how many hydrogen atom is present? 2 hydrogen atoms are present. 1 oxygen atom is present. That means water has a fixed formula, that is H2O. In water molecule or in water, there should be a 2 hydrogen atom and there should be a 1 oxygen atom. It is fixed. Okay, so this is the meaning of fixed composition. Same way, if I take one more example as a carbon dioxide. Okay, carbon dioxide gas. Now it is a pure substance. Only carbon dioxide particles are present in a carbon dioxide gas. Now what is the formula of carbon dioxide? As you know that formula of carbon dioxide is CO2. That means 1 carbon atom and 2 oxygen atom is present. So it is in a fixed composition. Okay, it is in a fixed composition. I can't say that carbon dioxide formula is CO3. It is exactly wrong. Carbon dioxide is always CO2. That means 1 carbon and 2 oxygen should be present. So this is called as a fixed composition. So I will repeat again. What is a pure substance? Pure substance are made up of, or those substance which is made up of a single component or only one kind of component with a fixed composition. Okay, now so we'll move on to the next one. Pure substance, again classified as elements and compounds. Now what is the meaning of elements? Here, see the slide. Elements, it is consist only one type of particle. It consists only one type of particle, either in the form of atoms or in the form of molecule. Okay. Now, here, I will again move back. I will show the classification again. Now here, elements again classified as atom and molecule. This term you already studied in your lower class. Now, what is the meaning of atom? Atom is a smallest particle. It's the smallest particle of an element. It's the smallest particle of an element. We cannot break this smallest particle. Okay, we cannot break this smallest particle. Now, what is the meaning of molecule? Molecule means molecules are formed by the combination of atoms of the same element. I think you can see the picture of this. Maybe it is not more clearly pictured. Okay. Now, hydrogen molecule, if I take hydrogen molecule, formula of hydrogen molecule is H2. That means combination of 2 hydrogen atom. It is formed by the combination of 2 hydrogen atom. Same way, one more example you can see on the slide as oxygen molecule. O2, formula of oxygen molecule is O2. It is formed by the combination of 2 oxygen atom. Okay, one more example is given. Chlorine molecule formula is Cl2. It is formed by the combination of 2 chlorine atom. Okay, so these are the example of a molecule. Now, atom it is given as a helium as example. Okay. Now, next, to more clear, I will explain the concept of element, atom and molecule with an example. Okay. Imagine that you have a thermocol. Everyone have seen thermocol sheet. Okay. Now thermocol sheet, entire thermocol sheet, consider as an element. Okay. Consider as an element. It contains only one type of particle. It contains only one type of particle. Now, if you observe more clearly, thermocol sheet, it has a hexagonal ring, a small boxes you can see. Okay, it is a hexagonal ring. Okay, so many hexagonal rings are joined to form a big thermocol sheet. Okay, now entire thermocol sheet I will consider as an element. Okay, in that I will take one small hexagonal ring. That small hexagonal ring I will consider as an atom. I hope now you understood what is the difference between element and atom. Okay, so smallest hexagonal ring I will take from the thermocol sheet. So that I will consider as an atom. For the molecule, what I will do, take one more hexagonal sheet from the thermocol sheet. Okay, I will take one more hexagonal ring or small particle from the thermocol sheet. Okay, now the two particles I will link, I will connect, or I will combine. So this is called as a molecule. I hope you understood the difference between elements, atom and molecules. Okay, now one more type, it is a compounds. Now, what are compounds? Compounds are formed by the combination of different two or more atoms of different elements. Compounds are formed by the combination of two or more atoms of different elements. So underline that, two or more atoms of different elements. Now here, see that. Now find out the difference between molecules and compounds. In a molecules, it is a combination of two or more atoms of same element. Same element. I already given the example as hydrogen molecule. Hydrogen molecule is a combination of two hydrogen atom. Oxygen molecule is a combination of two oxygen atom. Chlorine molecule is a combination of two chlorine atoms. Okay. But in the case of compounds, it is nothing but a combination of two or more atoms of different elements. Okay. Now, you can see one more example on the slide as a water molecule. Now water, as I already told, what is the formula of water? H2O. That means two hydrogen atom, one oxygen atom is present. Two hydrogen atoms and one oxygen atom is present. Here, water molecules are, or water is formed by two atoms. Okay, two atoms of different elements. Okay, two atoms of different elements, that is hydrogen and oxygen, both are atom of different elements. Hydrogen is different and oxygen is different. Okay, so compounds are formed by the combination of two or more atoms of different elements. I hope you understood the difference between elements, atom, molecule and compounds. Now, next, that is characteristic of compounds. What are the characteristic of compounds? Here, the first point is given as atoms of different elements are present in a fixed and a definite ratio. What is the meaning of first point? As I told, the definition of compounds are formed by the combination of two or more atoms of different elements. Example I have given as a water molecule. water molecule, the formula is H2 water formula is H2O. Okay, that means there are 2 hydrogen atom and 1 oxygen atom. That means different atoms of different elements. Hydrogen atom, oxygen atom. So atoms of different elements present in a fixed ratio. Now present in a fixed ratio means, what is the formula of water? It is H2O. That means in H2O there are 2 hydrogen atoms should be present and 1 oxygen atom should be present. Then only I can call it as formula of water as H2O. Okay. Same way, if I take carbon dioxide. Now carbon dioxide, it is formed by atom, that is 2 atoms, carbon and oxygen of different elements. Carbon and oxygen of different elements. Now here in a carbon dioxide, what is the formula of carbon dioxide? CO2. That means 1 carbon atom and 2 oxygen atoms are present. So it is in a fixed ratio. That means carbon should be present in a 1 ratio and oxygen should be present in a 2. That means the ratio is 1:2. 1:2. That means it is a fixed ratio. Okay. I hope you understood the first point. The next one, the properties of the compounds are different from those of its constituent elements. Properties of the compound. Now, suppose if I take an example of water. Okay. Now, water is in which state? Liquid state. Now, usually, water is formed by actually the equation is written as in the form of H2 plus O2. It gives as a H2O. Okay. Now here H2, that means hydrogen molecule always in the gaseous state. Oxygen O2, it is always in the gaseous state. Now when H2 and O2 combines to form a H2O. Now H2O, it is in a liquid state. Now reactants are in a gaseous state, but formed product are in a liquid state. That means properties of the compound are different. That means which product is formed? Water is formed as a product. That is in which state? Liquid state. From how it is formed? By the combination of hydrogen and oxygen. Hydrogen and oxygen always in a gaseous state. So the properties of the water, that means product or compound, is entirely different from the reactant. Okay. Now the next third point, the constant of a compound cannot be separated by physical method. Now same example I will take H2O, water molecule. Now here water molecule it is very difficult to separate by physical methods. Physical method means it is very difficult to separate by distillation or a fractional distillation. But it can be, constant particles can be separated from the compound by chemical methods. Now, next classification. As I already told, based on the chemical classification, matter, I will show you again I will show you chemical classification. Matter is classified as pure substance and mixture. Pure substance is again classified as element and compound. Now we are moving to the next classification, in the sense next part is mixture. Now what is the definition of mixture? Now here mixture classified as homogeneous mixture and a heterogeneous mixture. Now what is the definition of mixture? Now word itself, it defines. The mixture word itself defines the term, that is, mixture consists of two or more substances present in any ratio. There is no fixed ratio, any ratio or variable ratio. That means here already example I have written on the slide, that is salt solution in water. That means take 1 or 2 spoon of salt, put it into water, stir it well. It is a salt solution. Okay. Now in another side, to the water add mud and sand, stir it, okay, and keep it aside. Okay. In the first example, what I told as a salt solution, it is clear solution. Okay. You can't identify that it is a salt solution unless you taste. After tasting only you can identify that this is a salt solution. But in the second example, that is a mixture of mud and sand in water, clearly you can understand by seeing only, you can identify that this is a mud and sand is mixed in a water. Mud and sand settles at the bottom of the beaker. Okay. Now here, 2 or more substances. Here in the first example, what are the substances? Salt I added to the water. So 2 or more substances present in any ratio. It is not in a fixed ratio. I can add 2 spoon of salt or 3 spoon of salt or 4 spoon of salt. It is my wish. Same way in the second example also, mud and sand. Okay. In any quantity I can add mud and sand to the water. So in a mixture, it is a mixing of, or it consists of 2 or more substance present in any ratio or a variable ratio. But in the case of compound, here also combination of 2 or more atoms of different element in a fixed ratio. But in the case of mixture, there is no fixed ratio. It is ratio is a varies ratio. We can vary the ratio. Okay, fine. Next, what is the next? Mixture again classified as homogeneous mixture and heterogeneous mixture. Now, see above example I have given as a salt solution and a mixture of mud and sand in the water. Here only we can identify which one is a homogeneous mixture and which one is a heterogeneous mixture. Salt solution in water is a homogeneous mixture, and one more example, mud and sand in the water is a heterogeneous mixture. Now in this case of a homogeneous mixture, salt solution, after mixing salt in water, you cannot find any salt particles in water. You can see just a water molecules. You can see only water. Okay, that is only after tasting you can identify that this is a salt solution. That means components, that is a salt, are completely mixed with each other. It is completely mixed with each other, and its composition is uniform throughout. Composition is uniformly mixed throughout the solution. That's why you can't identify any particles in the water. Okay, since it is uniformly mixed each other, uniformly distributed throughout the solution, you cannot find any salt particles in the water. Okay, next, that is a heterogeneous mixture. Now in heterogeneous mixture, sand and mud in water, you can clearly identify sand and mud settles at the bottom of the beaker. Okay, now here components are not mixed uniformly, thoroughly throughout the solution. So you can identify 2 layers or 3 layers like that. Okay. Now, next topic is properties of matter and their measurement. Now, properties of matter. Properties of matter are classified as two types, as a physical properties and chemical properties. Now, physical properties are those properties which can be measured or observed without changing the identity or the composition of the substance. The properties which can be measured or observed. Now, how it is measured and how it is observed? In the animated video, it is already explained. Example is taken as that is yellowish rubber ball and yellowish sulfur, yellowish colored sulfur. Now, what are the measured and observed properties? First, what are the observation? What are the observation? Okay. Now, here, what and all we can observe? That is a yellow rubber ball, and next one, it is a yellowish sulfur compound. Substance, yellowish sulfur substance. Okay, here both are solid. So this is observation. Both are solid. Okay. Now, color. What is observation color? It is a yellow color. Okay, that I observed or you observed. Okay. Then after that, next, what is a smell? Smell. Rubber ball smells like rubber. Sulfur, it has a strong odor. Odor means it is a nothing but a smell. Okay, so these are the properties. Properties are assigned by observing. Okay, properties are explained by observing the matter or substance. Okay, now measured. How it is measured? Measured in the sense how much it weighs. What is the weight of rubber ball, or what is the weight of sulfur? Okay, what is the texture of sulfur, or what is the texture of rubber? All these properties, or what is the melting point of rubber, or what is the melting point of sulfur, all these are measured one. So physical properties means these are those properties which can be measured or observed without changing the identity, or composition of the substance. Okay. Now, chemical properties. Actually, by observing only physical properties, this is not sufficient to explain the properties of matter. So, chemical properties are also required to explain the properties of matter. Okay. Now, what is the meaning of chemical properties? Chemical properties are those properties which can be measured or observed with the chemical change. Now, what is the meaning of chemical change? Okay. Now, chemical change means, here, suppose, if I take example as a sulfur, that is already given in the animated video. Okay, same thing I will explain here also. If I burn the sulfur, you will get a colored flame. So this is observation. Now, how colored flame is obtained? That is by heating the sulfur. So this is a chemical change. Okay, this is a chemical change. Here what happened? Sulfur start melting and chemical composition will also change. Composition is also change. Okay. So what is observation while heating? I can see a blue colored flame. Okay. Next. Now imagine that suppose if I add acid to the substance, any substance. Okay. There may be a change. Either color may be changed, or sometime reaction may take place. Fumes. Okay. Fumes may occur. So all these I can observe by doing the reactions. So chemical properties means I can measure or observe those properties by doing the chemical reactions. I can measure or observe those properties by doing chemical reactions. Okay. Now the next one, measurement. Now measurement, here in chemistry we are using international system of unit. International system of unit. Now measurement, here imagine that, suppose if I say I have 100 gram of glucose, 100 gram of glucose. Okay. Now 100 is a number, gram is a unit. Okay. Now here in a chemistry we are using an international system of unit, that is called as a SI system. SI system. Now you can see on the slide a table I have given, that is there are 7 base units, 7 base units which we are using in a chemistry. Okay, or I can call it as in science, that is length, mass, time, electric current, temperature, amount of substance, luminous intensity. Now length, what is the symbol of length? That is L we are using, small letter L. Now what is the name of the SI unit? How we are measuring the length? It is a 1 meter, 2 meter. Okay, so SI unit of length is meter, and symbol it is written as a small letter M. So same way you can see all the units. Okay, these are 7 base units. 7 base units. These are very important. Okay, very important in chemistry as well as in physics. Okay, this you have to recall. Okay, now other quantities, other measurement, mass and weight. Now is it mass and weight is same or different? Now mass and weight is entirely different. Mass and weight is entirely different. Now mass means, mass is a substance, it is a amount of matter present in it. That is a amount of matter. Mass means it is nothing but a amount of matter present in it. Weight means it is a measure of how the force of gravity or a gravitational force act upon that mass. Okay, so mass is, it is a constant. Mass is a constant, but weight is it varies. It varies based on the gravitational force. Based on the gravitational force. Okay. Now, so what is the SI unit of mass? SI unit of mass is what is SI unit of mass? It is nothing but a kilogram, that is kg. Okay, next quantity, that is a volume. So volume, this you already studied I think in your lower class. Volume means it is nothing but a length into breadth into height. Okay, length into breadth into height. So based on that I can write SI unit for the volume is meter cube. M into M. Length, breadth and height. All these terms are measured in terms of meter. So M into M, that is meter cube. So SI unit of volume is meter cube. Okay. Now other common units are also used to measure volume, that is like 1 liter. So 1 liter is equal to 1000 ml, and this is also equal to 1000 centimeter cube, and this is also equal to 1 decimeter cube. Okay, all these conversion are very important for the problems. So you should remember and write in your notes or highlight in your notes. Okay, now next quantity is density. So density, what is the meaning of density? Density means it is nothing but a mass of a substance per unit volume. Mass of a substance per unit volume. Okay, per unit volume. Now here, so this is very important question. Usually question is asked, what is density or define density, and write SI unit of density. Okay, the SI unit of density. So what is the definition of density? It is nothing but a mass of a substance per unit volume, or a mass by volume. Like that also you can write. Density is equal to mass by volume. So what is a unit of SI unit of density? So it is a kg per meter cube. Mass divided by volume. So mass means it is a SI unit of mass is kg. Volume SI unit is a meter cube. So based on that, SI unit of density is equal to kg by meter cube, or kg per meter cube. Okay, the next unit is, next quantity is a temperature. Now as you know that temperature is measured in terms of degree Celsius, degree Fahrenheit and Kelvin. Okay, but here we are more concentrating on Kelvin. So Kelvin is the SI unit of temperature. Kelvin is the SI unit of temperature. This is also very important question. What is a SI unit of temperature? So Kelvin. Okay, now there is a conversion formula, that is degree Celsius is converted into Kelvin by using this formula, that is K is equal to degree Celsius plus 273.15. Okay, that is degree Celsius is equal to 273.15. Okay, so based on that, how it can be converted? By using this formula, that is K is equal to degree Celsius plus 273.15. I will work out few problems regarding this conversion. Now, how to convert 25 degrees Celsius into Kelvin? Formula is written, that is K is equal to degree Celsius plus 273 Kelvin. Here, in the place of degree Celsius, you should put the value, that is 25 plus 273.15. So what is answer you will get? It is 298.15. Okay. Now calculation method is given here only. How it is calculated? Now one more problem. Convert 30 degrees Celsius into Kelvin. First, apply the formula, that is K is equal to degree Celsius plus 273.15. Then in the place of degree Celsius, substitute the value that is given in the question as a 30 degree, okay, plus 273.15. So you will get the answer as 303.15. Now I have given a homework. Convert 45 degrees Celsius into Kelvin, and one more, it is 27 degrees Celsius into Kelvin. Okay, try by yourself. These questions are very important for the exam. Now, next, that is uncertainty in measurement. Okay, now what is the meaning of uncertainty in measurement? Now, chemical properties as well as physical properties involves measurement. That is, these measurement involves numerical value. Suppose, if I say 100 gram of glucose, 100 gram of glucose or 100 gram of salt. What is the meaning of that? 100, it is a numerical value. Gram is the measurement. Okay, it is a measurement of mass. Now here, uncertainty in measurement, under that there is one topic, it is called as a scientific notation. Now what is the meaning of scientific notation? Now first, why? Now when scientific notations are used, why scientific notations are used in chemistry, that you should know first. Okay, before understanding the definition, you should know why scientific notations are used in chemistry. Now actually I already told that chemistry, it deals with the matter. Now matter, it is nothing but a large number of atoms are present. Matter consists a large number of atom. Okay, now atom, first of all, atom is the smallest particle, so that means which has a extremely low masses. Atom itself, it is a very smallest particle, so that so its mass is extremely low mass, and it contains in a large number. So what happened during the calculation, scientist or chemist faced many problems to solve the calculations. So many problems to solve the calculations. That means they faced a very big numbers. Okay. Now these large numbers can be converted, or large or small numbers can be converted into a scientific notation with the help of n into 10 to the power n. That is, so definition is, scientific notation means it is nothing but a exponential notation in which any number is represented in the form of n into 10 to the power n. Now here you can see in this, small letter n is an exponent having positive or negative value. Capital letter N, it is nothing but a digits. Now example I have given, that is 3068456.23 can be written as 3.0684563 into 10 to the power 6. Okay, and here what happened, see the decimal point. This decimal point I shifted to left side. That is shifted to left side by 6 places. Okay, since it is shifted to left side, I have written in the form of 10 to the power plus 6. Okay, in the second example, see here 0.000023. It is very difficult to say the number. Even it is very difficult to put it in a calculator also. It is very difficult to calculate. Okay, so what we can do, this we can simplify. This number we can simplify with the help of scientific notation. That is, see the decimal point. Okay, that decimal point is shifted to the right side. Okay, so it is written as 2.3 into 10 to the power minus 7. Now that means how many decimal point is moved or shifted to the right by 7 places. Since it is shifted to right side, it is written as minus 7. If point is shifted to left side, it is written as plus. If decimal point is shifted to right side, then it is written as, number is written as, or exponent is written as minus value. 2 more example is given here. You can watch it. Now one more example, you can see here, I have written as 236,789.63. I don't want to use such a big number in the calculator. So what I will do, I will convert into a smallest number. Okay. Now here, this I will convert into a scientific notation. See how I shifting the point. See, this is a decimal point. I will shift to the left side. So 1, 2, 3, 4, 5. Here I will stop. Okay, now this I will write it in the form of scientific notation, that is n into 10 to the power n. Now n here I will write 2 point, here I stop the point, 3 6 7 8 9 6 3 into 10 to the power. Now how many point I shifted? 1 2 3 4 5. So 5 point I shifted, 5 point I shifted to left side, so it is a plus 5. Okay, so only 5 I will write. Okay, so this is a format of writing scientific notation. Now one more example I will take, that is 0. One more example I have taken, that is 0.00002368. Now this also I can write it in a scientific notation, that is n into 10 to the power n. Now here just see 1 2 3 4 5. Okay, so here I will write 2.368 into 10 to the power. Now how many point I shifted? 1 2 3 4 5. So since it is to the right side, so I will write as a minus 5. If point is shifted to the right side, so it is written in the form of minus sign. Here in the above, point is shifted to the left side, so it is written in the form of a plus. Okay, students, I have given a homework, that is first one and the second one. Try by yourself and send the answer through WhatsApp. Okay, I hope you understood the scientific notation. Next we'll move on to the next topic as significant figures. Now what is the meaning of significant figures? Certainty and uncertainty in measurement is indicated through significant figures. That means significant figures are meaningful digits which are known with the certainty. Suppose, imagine that I have a measurement of water. Okay, here I have given the example as 13.2 milliliter. Okay, I measure water as 13.2 milliliter. Okay, now in this measurement 13 is a certain and 2 is uncertain. Now what is the meaning of this? Now I measured as 13.2 milliliter. I may ask one more person to measure same amount of water. I may ask one more person to measure same amount of water. Okay, he or she may measure as 13.1 milliliter. 13.1 milliliter. Okay, now here 13 is a certain, but 0.1, what happened? My measurement, what I measured as 13.2, but I asked one more person, he or she measured as 13.1. It is less than my measurement. It is less than my measurement. And same amount of water, I may ask one more person to measure. I may ask one more person to measure. Okay, so here he or she may measure as 13.3 milliliter. 13.3 milliliter. Now here I am comparing the values. Okay, now my measurement is 13.2, but third person, he or she measured as 13.3. That means it is a more than 0.2. Okay, so here what happened? 0.2. Okay, and second person measured as a 13.1. Third person measured as a 13.3. Now, so 0.2, 0.1, 0.3 numbers are uncertain. It may vary person to person. It may differ from one person to another person based on his or her observation. Okay, but 13 number, it will not vary. It is a certain number. I hope you understood the concept. Now, the rules to determine significant figures. What are the rules to determine the significant figures? Actually, no need of biting these rules, but application based questions will be asked based on this topic. Okay, I will tell you later how question will be asked. Now first I will explain the rules. Okay, the first rule, it says all non-zero digits are significant. All non-zero digits other than 0, non-zero digits, okay, means other than 0, rest of the numbers are significant. Now example is given as 2, 4, 5, 6. Now in this any 0 number is there? No. So that is a 2, 4, 5, 6. How many digits are present? 1, 2, 3, 4. So 4 significant figures are present. Okay. Now zeros proceeding to first non-zero digits. Zeros proceeding to first non-zero digits are not significant. Now that is, example is given 0.002. Now starting, you can see 0, you can see the zeros. That zeros are uncertain. That zeros are uncertain, or I can call it as it is not a significant. So 0.002, that number 2 is there, no? That is a significant. So how many digits are present? Only 1 digits are present. So here it contains only one significant figure. Okay. Next, one more example is given. You can see 0.000000234. The first zeros, okay, first zeros are not significant. So rest of the number, that is 2, 3, 4. How many digits are present? 3 digits are present. So this example has 3 significant figures. Next, third rule, zeros between 2 non-zero digits are significant. That means if 0 present between 2 non-zero digits, then that zeros are significant. For example, now 20034. Okay, now here zeros are present between non-zero digits. Zeros are present between non-zero digits. Okay, so you have to count all the numbers. You have to count all the numbers. Now, so how many digits are present in the given example? Totally 5 digits are present. So this example has a 5 significant figure. Okay, now one more example is given. 3040504. Okay, zeros are present in between non-zero digits. Okay, so all these numbers are significant. So you have to consider all digits are significant. That means how many digits are present in this number? So total 7 numbers are present. So this example has a 7 significant figure. Now one more, fourth rule, terminal zeros are significant. Terminal zeros means end, zeros present at the end. Okay, terminal zeros are significant if it is present on the right side of the decimal point. Right side of the decimal point. So example is given 0.200. Now after 2 there are zeros. So that zeros are called as a terminal zeros. That means zeros present at the end. Zeros present at the end. Okay. Now here, since decimal point is present, terminal zeros are considered as a significant. Since decimal point is present, terminal zeros are considered as a significant. Okay, ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಇದ್ದ ಕಾರಣ ಕೊನೆಯಲ್ಲಿದ್ದ ಝೀರೋ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಲಾಗುತ್ತದೆ. ಬೇಸ್ಡ್ ಆನ್ ದ್ಯಾಟ್ 0.200 has how many significant figures? 3 significant figures. Now one more example is given, 0.2000. Okay, now how many terminal zeros are present? Three terminal zeros are present. Now here in this example decimal point is present. Okay, terminal zeros are present at the right side of the decimal point. Okay, so this zeros are considered as a significant figures. So how many digits are present after decimal point? So 1 2 3 4. So 4 significant figures are present. Okay, now one more condition, that is terminal zeros. Again, what is the meaning of terminal zeros? Zeros are present at the end. Zeros are present at the end. Now here terminal zeros are not significant if they are not to the right side of the decimal point. Suppose, now example is given, 200. Now in this, is there any decimal point? There is no decimal point. Okay, so if there is no decimal point, then terminal zeros are not significant. If there is no decimal point, ಒಂದು ವೇಳೆ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಇಲ್ಲದಿದ್ದರೆ ಆ ಎಂಡಲ್ಲಿದ್ದ ಝೀರೋಸ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ ಅಲ್ಲ. Based on that, 200 has how many significant figures? Only one significant figures. Only one significant figure. Okay, now one more example I have given as a 2000. 2000 has. Now is there any decimal point? There is no decimal point. So terminal zeros present at the end are not a significant. So based on that, how many digits are present? Only one digit is present. So it has, this example has a one significant figure. The last rule, fifth rule. Okay, when numbers are written in scientific notation. Now scientific notation you already understood, that is numbers are written in the form of n into 10 to the power n. If numbers are written in a scientific notation, then all the digits are considered as a significant. All the digits are considered as a significant. Now example is given, 5.06 into 10 to the power 4. So this is a scientific, this number is written in the form of a scientific notation. So all number you should consider as a significant. So how many numbers are present? That is 5.06. So 3 digits are present. So this example has a 3 significant figure. Same way, one more example is given, 5.060 into 10 to the power 4. Again, this is written in the form of a scientific notation, that is n into 10 to the power n. Okay, now 5.060, how many digits are present in this? 4 digits are present. So this example has a 4 significant figure. Now one more example, 5.0600 into 10 to the power 4. Again, this number is written in the form of a scientific notation. Okay, that is n into 10 to the power n. Now here 5.0600 has how many digits? It is a 5 digits. So this example has a 5 significant figures. Okay, I hope you understood. Go through again this rule. Okay, now here problems I have given as a homework. Now write significant figures for the following. Okay, write the answer and send to me personally through a WhatsApp. Okay, so that I can understand you understood the topic. Now here you can see interconversion of water. Actually in the previous slide you are unable to see the picture. 3 states are interconvertible, I explained. Okay, so this you can see the slide. Ice is, ice, it is in the solid state. with the on heating, what happened, it is converted into water, that is in the liquid state. On heating, it is converted into vapor, that is in a gaseous state. Okay, while cooling, what happened, gas on cooling, gas condensed into a water, that is in a liquid state. Again, water on cooling, it is converted into ice. So these three states are interconversion of water. Explanation I already given, only picture it was missing on that slide. So again I am showing these pictures, okay, so that you can understand more clearly. Now this is a picture about a pure substance. Okay, pure substance. Now pure substance, what I told, what is the definition of pure substance? Pure substance are those substance which is made up of only one kind of component or a single component, either in the form of atom or either in the form of a molecule. Now see the first example, diamond is given. Now diamond it contains a carbon particles, only carbon particles are present. Okay, so it is a pure substance. Now here second example, water it contains only water molecules, there is no other content is present, so it is a pure substance. And then one more third picture, it is a zinc. Okay, it is a zinc. Now here only zinc particles are present, so it is a pure substance. And the next fourth picture, it is a copper. Okay, copper wire. Now here also it is made up of only copper particles, so it is a pure substance. So this is an example for a pure substance. Next, one more picture, that is I explained element, atom and molecule, then compound. So what are the differences between element, atom, molecule and compound? Now element, it is a single type of particle is present. Okay, now atom it is a smallest particle of an element. Atom is the smallest particle of an element. Now here it is given helium as an element. Now how molecules are formed? Molecules by the combination of atoms of a same element. Atoms of same element. Here you can see hydrogen molecule. Hydrogen molecule is formed by the combining of two hydrogen atoms. Formed by the combining of two hydrogen atoms. Okay. Next, oxygen molecule it is given. Here also oxygen molecule is formed by the combination of two oxygen atoms of the same element. Both are same element. Even chlorine also. Chlorine molecule is formed by the combination of two chlorine atoms of the same element. Both are same. Okay. But in the case of compound, you can see that is a water molecule. You can see the picture. That is H2O. Here it is in a what is the definition of compound? Compound, two or more atoms are combined in a fixed ratio. Two or more atoms of different elements are combined in a fixed ratio. Now what is the meaning of fixed ratio? I already explained. H2O. Now in H2O, how many H should be present? How many hydrogen atoms should be present? 2. And oxygen, how many oxygen should be present? 1. So this is a fixed ratio. Okay. Now here it is a combination of two or more atoms of different element. Hydrogen, okay, one atom. Oxygen is one atom. Hydrogen and oxygen atom is it is different. It is different atoms. Different atoms of different elements. Okay. So molecule, atoms of same element. Compounds, atoms of different elements. Atoms of different elements. So this is a picture. Okay. Now, so stay home, stay safe. Thank you.